So given that y and x cubed have a direct variation in relationship, find the percentage change in y whenever x decreases by 20%. So we start out with this equation where y and x cubed have a direct variation relationship. Okay, and of course we have to specify that k is never 0. Otherwise this equation would be meaningless. Okay, so we start out with an original value of x. We call that x1. Okay, so if I give you some tips here, okay, we are going to draw this table here. This table will be very useful. Okay, although we don't need to write it out for our solution. Okay, so we start off with x1 as our original value of x. If this is the equation, of course, we know that the y would just be k times x1 cubed. Now, there is a change to the original value of x. It decreases by 20%. So the new value of x would be 0.8 x1 because from here to here it decreases by 20% because of this. So if the new x is 0.8 x1, what is the new y? I just put this whole thing all substituted into the place of x. Alright, so it will be like this because this whole thing goes into whatever the x is. It's like a function, right? Now the question asks, what is the percentage change in y? So in other words, if I go from here to here, what will be the percentage change? So this is the whole story. So when I write out my solutions, I state out my original value of y, which is this one. And I will also have to tell the reader the new x. Last but not least, the new y. So after you simplify it, you get 0.512 kx1 cubed. Okay, now you notice that so far we have not found the value of k. Okay, but in terms of this kind of question, when we talk about percentage change, okay, we don't really care about the value of k. Now, what next? Back to Form 1 mathematics. So the percentage change in y is just new y minus old y over the old y, the original y, times 100%. In order to do that, there's a lot to factorize out and there's a lot of canceling. At the end, you will end up with numbers only because you can take out the k and the x1 cubed, which most of the time would be exactly the same as your denominator, which you can cancel out. And so you will end up with an actual number without all the unknowns here. So what's the key? The key is establishing the equation and you substitute into this place of x your original value of x, which is x1, to get the original y. And for the new y, you put in the new x, the entire thing inside the x. Okay. So conceptually, what's this all about? So let's say I start out with 100 for the x. Then for the y, I would have 1 million k. All right. So if I change it to 80% of 100, my new x will be 80. All right. And so if I put 80 in here for the new x, you calculate the whole thing, you end up with 512,000 k, and that is a decrease of 48.8%.